reciprocal leveling. It is one of the important method of leveling. This method is preferred when it is not possible to set the instrument midway between 2 points. Reciprocal leveling is performed to determine the true difference of level between 2 points which are located on opposite banks of a river, and all the errors are eliminated using this method of leveling. Let's consider a pond or a river or any water body or a depression. See, this is left bank of a, say this is a river, left bank of a river. This is the right bank of a river. Say the instrument is located on the left bank of a river and staff is hold near to this setup of instrument. Say it is point A and another staff is held on the right side bank of a river. Say it is B point. From this instrument, observe the staff reading on A. This is A1, and observe staff reading on B. This is B1. Now, when the instrument is set at the right side bank of a river, the points of leveling stations are at the same locations. Observe the staff reading from here. This is B2. This is the instrument, the staff reading is B2, and this is A2. Point B is located nearer to instrument. This is the true level difference between A and B points. Say it is H. When the instrument is near to A, correct staff reading at A is equal to A1. When the staff reading observed on B, when the instrument is near to A, is B1. But considering the line of collimation, if it is a level line, and this may be the horizontal line, and this is the line of collimation. If the line of collimation is not being horizontal, there may be a chance of occurring error. And this is the level line, and this is the horizontal line. This is the line of collimation. Similarly, when the instrument is near to B point, this is level line. This may be the horizontal line. This is the line of collimation. Now, correct staff reading at A is A1 when the instrument is near to A. Correct staff reading at A when the instrument is near to A point is A1, and correct staff reading at B is equal to B1 minus E. At B is equal to B1 minus E. This is the B1. When the instrument is at this bank, that is near to B, correct staff reading at B is B2, correct staff reading at A is A2 minus E. Correct staff reading when the instrument is in the left bank or when the instrument is near to A. When the instrument is set up near to A. When the instrument is set up near to B. Correct staff reading at A is equal to A2 minus E. Correct staff reading at B is equal to B2. Here the ground profile is lower than the ground profile at B. So A is in lower elevation, B is in higher elevation. Now write H value. A1 minus B1 minus E. Say this is equation 1. When the instrument near to B, write true difference between 2 points A and B is A2 minus E minus B2. This is second equation. To get the true difference between 2 points located on opposite banks of a river, add these two equations. 1 plus 2 is equal to A1 minus B1 minus E plus A2 minus E minus B2 is equal to H plus H. A1 minus B1 plus E plus A2 minus E minus B2 is equal to 2H. Cancel E and E. A1 minus B1 plus A2 minus B2 is equal to 2H. H is equal to A1 minus B1 plus A2 minus B2 divided by 2. So H is the true difference of level between A and B. So A1 minus B1 plus A2 minus B2 divided by 2, which is the mean of the two apparent difference of level. Mean of the two apparent difference of level. Now find the error that including the combined error in the staff at the farthest point due to curvature and reflection and collimation is not being horizontal. Say it is E. We can get this one by equating 1 to 2. One equation is A1 minus B1 minus E is equal to A2 minus E minus B2. A1 minus B1 minus C is equal to A2 minus E minus B2. A1 minus B1 plus C1. Now A1 minus B1 plus C, so you get this E value here, plus E plus E is equal to A2 minus B2. 2E is equal to A2 minus B2. You send this factor to this side, minus A1 minus B1. E is equal to A2 minus B2 minus A1 minus B1 divided by 2. We know combined error due to curvature and refraction is equal to 0.0673 d square, where t is the distance in kilometers. We can determine collimation error in the instrument, which is equal to E minus combined correction due to curvature and refraction. We know E is A2 minus B2 minus A1 minus B1 by 2. Reciprocal level is performed between 2 points A and B are fixed on opposite banks of a river. The observed staff readings are given below. The distance between A and B is 1555 meters. The table has given here. Leveling instrument is set near A, near B. When it is set near A, the staff readings on A is 1.25, on B 2.15. When the instrument is set near B, staff reading on A is 0.95 meters. Staff reading on B is 1.35 meters. Determine true difference in levels between A and B. Number 2, total error. Number 3, collimation error. So in reciprocal leveling, the instrument is set here and observe the staff reading on A. It is 1.25. It may be the depression or a river. From this setup of instrument, observe the staff reading on B, which is on the opposite bank of a river, which is 2.15. It is 1.25 meters, and on B it may be like this. The staff reading is 2.15 meters. Next, instrument is shifted to this side. Set the instrument here and observe the staff readings on A and on B. On B it is 1.35 meters. On A it is 0.95 meters. Which is 0.950 meters. From this data, we can determine the true difference in levels between A and B. A1 minus B1 plus A2 minus B2 divided by 2. This is A1, this is B1, this one is A2, this one is B2. Two difference between two levels is 1.25 minus 2.15 plus 0.95 minus 1.35 divided by 2. H is equal to minus 0.65 meters, which means A is at this RN, B is here. The difference between these 2 points, two levels, is 0.650 meters. Here, minus value indicates there is a fall from A to B. Second one is total error occurred due to reciprocal leveling in between these 2 points. Total error E is equal to A2 minus B2 minus A1 minus B1 by 2. 0.95 minus 1.35 minus 1.25 minus 2.15 divided by 2. Total error is equal to 0.250 meters. Third question is collimation error. The collimation error is calculated by considering the combined effect of curvature and refraction. Combined curvature and refraction correction. CCR is equal to 0.0673 d square. Here d is the distance between A level and B level, which is given as 1.555 kilometers. 0.0673 into 1.555 square. CCR is equal to 0.162 meters. We know total error. We can get the collimation error by taking the difference between total error and correction due to curvature and refraction. Collimation error is equal to total error minus correction due to curvature and refraction. 0.25 minus 0.162. C is equal to 0.088 meters. The following table shows the reciprocal levels observed with a dumpy level instrument near to station A. Staff readings on A is 1.155, on B 2.755. When the instrument is near to station B, staff reading on A is 0.755, on B 1.925. The distance between A and B is 999 meters. Reduced level of P is 148.615 meters. Find the reduced level of A. Number 2, combined error for curvature and refraction. Number 3, total error. Number 4, collimation error in the instrument. Instrument is set here and observe the reading on A. There is a pond in between A and B. Staff reading on A is 1.155 meters. So this is A1. Staff reading on B when the instrument is near to A. Staff reading on B is 2.755 meters. This is B1. When the instrument is shifted to here, staff reading on A is 0.755 meters. This is A2. Staff reading on B is 1.925. This is B2. It is true difference in levels between A and B is equal to A1 minus B1 plus A2 minus B2 divided by 2. A1 1.155 minus 2.755 plus 0.755 minus 1.925 divided by 2. H is equal to minus 1.385 meters. Reducer level of B is given. Value is 148.615 meters. This minus value represents that this B position is lower than this position. So the difference between two points is 1.385 meters. We now reduce the level of B, which is 148.615. So reduced level of A is equal to reduced level of B plus this value. Reduced level of A is equal to reduced level of B plus H value, which is equal to 148.615 plus H is 1.385 meters, which is equal to 150.00 meters. Reduced level of A is 150.00. Second one is combined error for curvature and reflection. CCR is equal to 0.0673 D square. We know D is 999 meters. Zero point 0.0673, 0.999 whole square. We have to take the distance between A and B in kilometers. Therefore, correction due to curvature and reflection is equal to 0.067 meters. Third one, total error E is equal to A2 minus B2 minus A1 minus B1 divided by 2. Substitute the reciprocal levels Here A2 is 0.755 minus 1.925 minus A1 1.155 minus 2.755 all divided by 2. Total error will be 0.215 meters. Now fourth question is collimation error in the instrument C is equal to total error minus combined correction due to curvature and refraction. We have found these two values. C is equal to total error is 0.215 meters and combined correction due to curvature and refraction is 0.067 meters. Therefore, C is equal to 0.148 meters.